This meeting.
Oh, good. See, this is why we have John Williams host these things, so that he remembers to start the recording at the beginning.
Yeah.
Instead of at the end.
Yeah, but now you gotta answer, got it.
Okay, so, welcome all you Zoomers, welcome to people here in the hall. This is gonna be a slightly unusual, presentation night, as you've noticed in the past. Seems like every time we do something, there's another little twist, something we're doing a little differently. So what's gonna happen is, we're gonna save Mike Carroll's presentation for the last. He's doing his on his computer. So there'll be a moment there, which will probably turn into a minute or 2 or 3 or 9, where we do a computer swap, get his set up to be sending everything out from the meeting hall here. So and we have a couple other things we're going to do before then. We have Leonard's presentation, of course, and then we're going to have a nice little video of the aurora and some other things to talk about. So Barb, you will be the next person to talk to do some introduction things. You ready?
Hold your pants up on camera.
There are no secrets in this.
So remember that's your mic. Barb.
I got to
Remember that's your mic.
Yeah, so first of all, I'll pass out the June, you got the whole month, June 1st today. The sky calendar. And just right here. Yeah. So welcome everyone. One thing I wanted, well. Okay, our next meeting is 7 weeks from now, so it's July 20th, the very famous Apollo Day, and it's Alan Stern. And then we got Robert Subrin to reschedule. He's a Mars guy and head of the Mars Society for August 17th. So we have those two lined up. But in the next 7 weeks, maybe in like 3 weeks on a Friday, we want to do a star party. And we wondered, does that sound like, do you know, I think it's the 21st of June. Does that sound like something? Maybe raise your hand if you're interested. You know, whether you. Oh, yeah, that's true. So this would be.
Solstice.
Yeah, we should do it on a shorter day, right? So, yeah, what we'd like to do, we have our Park and Rec people involved. And they wanted us to do this at the school. So they have a new pavilion. If you haven't driven by there, when you're facing the school, it's just to the right. And we'd have a little talk there and then go down to the soccer field and have telescopes. And you can bring some refreshments. But they can't be on the soccer field because they don't want birds pecking around and food you've left behind. So, yeah, we'll have that off to the side. We've done this twice before in the last 10 years, but I think we've only had 8 or 10 people who's been to one of our star parties. Oh, look at that. Quite a few people. Okay. So it's really fun. Bring a blanket. You can just lay around on the soccer field and then get up and look through the telescopes. And I just, I'd like to see if we can get some volunteers, maybe, or some suggestions for activities. A long time ago, George was contacting me about the Fisk Planetarium, and they have some great shows down there. Maybe we could organize a trip to go down there at some point. George, is he here? There he is. Would you like to organize it? Or we'll work it out. Okay. And maybe a tour of one of the space companies. That could be Sierra Space, maybe. Could you, Stephen, organize something like that, maybe? Or get permission? Yeah. Okay, good. And I just want to appreciate and say thank you to all the people who help us, which is John Williams, who is hosting tonight. That takes a little pressure off of Dewey and I. And Dewey, of course, who sets up all this technology and keeps me on my toes. And Carolyn Collins-Peterson, who does our Facebook website. And And, you know, we maybe could use a little help, with John Williams and I are trying to update our website a bit. And he's recording this, so, he'll put that, I think, when he gets the chance on our website. And there are a lot of our other speakers who are on there. But anyone want to volunteer to help with the website? Yeah, I don't see hands. Okay, we'll work. Yeah, we'll work on that. So yeah, I think those are sort of the main things. You know, some of us went to the Wonderview Cafe before this. If you want to go, just let us know. Everyone's invited. I just have a list of some people who've gone before, but we'd be glad to add you to it. Everyone on their own dime, of course. I think those are the main things. Anyone have any questions or ideas for other activities that you'd like to do? No? Okay.
All right.
I want to thank the Mountain Messenger too. They've been great.
Yeah, thanks to the Mountain Messenger for, running our little stories here. And then, of course, thanks to the Coal Creek Canyon Park and Recreation District for sponsoring us. And I'll be honest with you, I don't know what it means that they sponsor us.
No, well, we did, I'll mention that later in the Leonard's talk, but they were the ones that had us come on the partial eclipse day. They bought 100 eclipse glasses for the kids.
Okay.
Oh, and Marion pointed out the sign out there says, not Sky Watchers, but Sky Matchers. So we're dating. So raise funds.
That changes everything.
Nowadays, okay, so that should be Leonard, right? And then,
I'll make mine quick. Things are happening as we talk.
before Leonard gets up here, I want to do something real quick since I have the slides up here. And that is Mark Kuchenreiter gave us a couple pictures of sunspots, which are interesting because just recently we had a huge aurora because of those sunspots. By the way, can I do a quick check and make sure everybody zooming can hear? So maybe Clark, if you can give me okay, good. Thank you, Clark. All right, so at least that much is working. So let me bring this down. I'm gonna do a quick
recording in progress.
Yep. I thought so. All right, now let me do this. Okay, so Mark, maybe you want to say anything about these?
Sure, yeah. Well, when you bring it up.
Yeah.
Okay, so that was May 11th.
Oh, yeah.
And I didn't hear about the aurora until way late at night on Friday. But I wanted to get the picture the next morning. And so I got that in the morning. I think May 11th was Saturday morning. And then it got cloudy. So, yeah, but at the 4 o'clock position there, I'm guessing that is the sunspot group 3664. Yeah. So that was the big prominent one. Yeah.
So that it already rotated past the Earth when the eruption happened, so we didn't get slammed straight on?
Well, it took 3 days. It took 3 days.
Okay, but like,
It was over here and
I know they had an aurora, but there was no massive power outage or anything.
Right.
Are the technologies that good now? It's risk or
It missed, I mean, it really is correct. It's.
There were reports of radio blackouts and stuff. The power grid had enough warning to know, the Space Weather Prediction Center gave them enough warning apparently so that they could, do their thing. Also, airlines flew different flights and the ISS folks did stuff too so that they wouldn't get blasted by it.
Yeah.
okay, ready for next?
Yep. And that's today. Yeah.
Yeah, so that's a different.
Yeah, right. I
26-day rotation.
think it got flipped somehow, but that's this morning around 10 a.m. Yeah. They gave it a new number.
It's
Um,
still 3691.
Yeah, I saw there was a new number, like, I don't know, I don't understand how what they do when they do that.
Probably because it's a slightly different latitude too.
Oh, okay,
Or
yeah,
maybe they don't count it as it goes around the backside and every time it comes around.
It takes 26,
front.
sun takes 26 days to rotate, so it won't be the same one, since they're only 15 days apart, right?
No, that's the same on.
No. 2660 or 3664 hasn't come into view yet.
Yes, it has. That's it. But it's got a new name now.
It's come that far around?
Yeah. 3 weeks later.
Okay.
Know your son, Fox.
sorry, that's what I got this morning,
Okay, thanks, Mark.
yeah.
Okay, so I'm gonna go ahead and get Leonard's presentation up here. And we will hand it over to him. Up share for a moment. Up share. Thank you. I should from the beginning. All right, Leonard, you ready?
Yeah.
Here's the magic wand.
Okay.
Hey, Dewey,
Sit down.
Dewey,
Yeah.
share screen, please.
I could have swore I did.
Well, sorry to
Yeah,
be a stickler then.
apparently not, huh? Oh, I selected the screen. I did not press the button that says share. Like, thank you, John.
Yay.
Yeah, better.
Can I just do the little arrow?
Yep, yeah.
Okay, there's a lot happening, as always, and it's kind of a big day today. We got another delay with the Boeing Starliner. This is a pretty interesting story with, you got two test pilots that are riding the Starliner up to the space station, and this is NASA put a lot of money into this, and Boeing has gone through a lot of introspection because of the aviation side of the company. And I do worry about whether or not some of that spills over into their space program aspects. But anyway, they got pretty far down on the countdown this morning. Two test pilots sitting there for quite a while, and then they got down to a minute and something, and then they had another delay. It could be recycled. It looks like for tomorrow. So we'll see. And but this is a new capability that NASA has, and Boeing's reputation is really on the line on this thing. And they're riding an Atlas vehicle, which is unique. We haven't had this kind of booster involved other than the early Mercury program with John Glenn's a totally different kind of vehicle, but it's an Atlas with a Centaur on it. And it's a little scary watching this one evolve, and hopefully everything will go correct, and we'll have a new capability at NASA to get up to the space station. This just, a news flash. The Chinese have successfully apparently landed on the far side of the moon about an hour and a half or so ago, and they apparently they're already digging into the soil and grabbing material. And also one of the unknowns about this mission is there's a mini rover attached that nobody understands why it's there, but apparently there is a rover attached. Nobody knows who built it or what it is, or we've seen pictures of it, but nobody's ever explained it. So this is going to be a very interesting couple days. They're going to be on site on the moon at the far side right now, digging around, put the samples in, They put the samples into an ascender, which goes up to an orbiter that will eventually bring all this stuff back. The whole mission, I think, takes about 56 days since launch to bring it back to samples. So it's pretty interesting. And you know what I'm really fascinated by is, as far as I'm concerned, they're practicing a Mars return sample. That has all the elements of the technology, of the phase technology, the components to bring back a sample from Mars in the 2030s, is what they're projecting. So anyway, this is a mission underway right as we speak. And looks like they've been successful with their landing, and we'll look forward to imagery, and they'll be cranking that out pretty soon, I would assume. So this is the area they're going down. Maybe Bob, we were just talking. Bob, you want to add anything about what's the significance of far side and where they're landing? Is it scientifically this is an important thing, or how does it fit into the big picture?
I don't know exactly where, I think they're landing on a Mari unit, so a basalt and not the actual ancient islands rocks, but those rocks are probably mixed in there. So
Yeah.
this is the South Pole Aiken Impact Basin. It's actually the Apollo crater. And it's been a priority of the United States space program for 2 decades now to return a sample from there. There were several missions, 2 or 3 missions on our side got into so-called phase A. They were, trying to compete for the final down select, and they didn't make it. And these were like, billion-dollar cap missions. So, we had a cost cap and couldn't get it done. Who knows how much this costs, but they're getting it done. So it's gonna be scientifically pretty important for the.
Yeah, they're ramping up. I mean, China, I mean, I beat this into you more times than you need to know, but this is the story to watch. These guys are moving along, and it's really interesting time between their way to do space and a communistic system versus capitalism, and where are we? So it's going to be very interesting. They have Chang'e 7 and 8. They're building up to what they call the International Lunar Research Station. They want to put in place again by the 2030 timeframe. So they're kind of moving along with, and they've got all the elements that they're putting together for a human lunar mission. So it's really a great story. This was a weird thing. I woke up and I got on my email, and somebody sent me you want to come to the conference on space piracy? I have enough trouble following just the normal stuff. And now I got to worry about space piracy, but this is actually, I looked into this and wrote the story about these guys, and it's an actual conference they want to hold next year. And it's going to be held at the Naval Academy, it looks like. And it's pretty interesting. It's just they've found a niche in the space conference market to create a symposium on space piracy. So stand by.
Space piracy, you hijacking spacecraft, you stealing their comms.
Yeah,
It's like James Bond, like swallow.
it's all part of it. It's kind of interesting, and I'm going, oh my God, I really had to dive into this, make sure this guy was real. So anyway, but it turned out to be pretty interesting, and they got some pretty good speakers already. So something to watch. One thing I followed last week quite a bit. We've had some really interesting space debris accidents coming in. This is a picture on the right of an Australian farmer that went out on his acreage and found all this stuff out there, and it turned out to be part of a SpaceX Dragon capsule. The SpaceX, the way it's designed, the Dragon capsule has what they call the trunk. The trunk has all kinds of stuff in it, but it gets ejected before the capsule comes back into the atmosphere and re-enters, but the trunk stays up there. So they have these trunks floating around from these Dragon missions. Turns out they re-enter, and for some reason, big chunks of the Space Dragon trunk make it down to the Earth. Not only in Australia many, many months ago, but it just happened. This is my good friend Brett from Space.com. He went over to North Carolina. This thing landed last week.
No.
And it shows you the scale of this stuff that's falling into, again, luckily nobody's been hurt. Even before this event last week, there was one in Canada. And here's on the left is the picture, same kind of hardware that has survived reentry and landed in Canada. Again, luckily nobody hurt. On the right, it turns out that the Australians actually found more pieces that's almost identical to this thing from Canada. I had a lot of fun trying to get the photos for every one of those and try to do a comparative thing. And sure enough, they're all the same. And SpaceX is quietly giving money to these folks. I don't know how much they're getting, but
I think they still legally own it.
they do, and that's part of the issue, you know. You know, if somebody gets killed, this will be a different story, because we got close not too long ago that I talked about here. We had an International Space Station pallet that was tossed off years and years ago. It took a long time, and eventually the pallet came in, and it came in over the United States, and it broke. The battery came in, or the housing of the battery, or whatever, some kind of fixture, came through a guy's home in Florida, and this guy, you know, he gave it to NASA to figure out what it was, and NASA eventually, a little bit of time to analyze it, said, "Yep, that's ours." And again, he's getting compensated for the hole in his roof as well as the floor that landed next to his son in another room. So that was a close call there. So anyway, I'm just another paranoid thing. The new thing coming with SpaceX and Elon Musk is the next Starship, the giant vehicle that he's built for making humanity a multi-planet species. He's had 3 of these flights, as you can see on the slides. The one on the right, I took this morning, a screen grab. It's sitting there in Boca Raton, or not Boca Raton, Boca Chica, Texas, getting ready to go from the starport that Elon has built for these flights. So we'll see. The FAA has got to give them a green light. Looks like they will. It could depart next week, June 6th. So keep an eye on that. There's nobody in it. It's just but it's a major test of the vehicle, and we'll see how well he does on this flight, because every one of the previous flights is certainly, who had a good comment about failure is an option, or whatever it was.
Fail forward.
Fail forward. I love that. Yeah, that's Elon's philosophy. I'm gonna fly these things till I get it right. And so anyway, keep an eye on that. And why it's important is that NASA has not cut bait with SpaceX on developing that Starship for the Artemis program to get astronauts on the moon. They've also contracted Blue Origin, which has sort of a competitive idea about how to get people on the moon later on in the program. But I keep an eye on Artemis with Starship. This story may change if he has a succession of failure. You're going to run out of runway at some point, and they're going to either have to cut bait with Elon or put him way down in the queue if we really are trying to get astronauts on the moon anytime soon.
Give us a year, Leonard. Give us a year.
Give us a year.
What year do you think they're probably gonna make it back to the moon?
NASA?
Either as SpaceX supposed to be #1 on the runway, or if Blue Origin laps them.
You know, I don't know. I go back to China. They're gonna be there waving at us when we come down. I don't know. They'll be putting, you know, construction, you know, pads for sale or I don't know what's gonna happen. It's the weirdest thing, you know. You got the NASA administrator. I just watched his whole testimony before Congress and, you know, he does his thing and then they get into Q&A. And, you know, Nelson's playing the China card. Unfortunately, China has a plane with a full deck. And, you know, Nelson's trying to get money out of Congress to make sure the Artemis stays on some kind of schedule that is somewhat, you know, aligned with what China's doing. But, you know, we got a long way to go. I'm nervous about all these things, but, yeah, I mean, I don't have any date for any NASA landing, but you know, my guess is this is gonna be a space race and they're gonna be pumping a lot of money in from Congress to try to make sure that we have a presence on the moon that's a human. So, yeah, it's a TBD. You know, as I get older, you know, you do the EKG and then you got the TBD. Okay. Thank you.
So,
Yeah. Byron has a couple, but I just.
oh,
Yeah, they're on that.
Okay. So Barb will now continue.
Yeah, just briefly. So, just want to inspire you to please come and help these kids at our local school. They're changing from the Jeffco school to, a charter school in the fall. So you were saying, who are these guys? Okay, that's me on the right, and the other three are the three hardworking women who run our local Coal Creek Canyon Park and Rec. And in August, I think it's August 10th, is the Mountain Fest that they run as a fundraiser. And they'd like some volunteers for that too. And it's really fun. We volunteered last year.
Volunteer?
So, yeah.
Is there a sign up
Just,
sheet?
yeah, we've got one at the back there. If you want to just write down that you'd be into helping, that'd be great. And yeah, they can get back to you on what they need, but, and they had the chicken poop contest, which you may not know about, but people sign up at little squares and wherever the chicken poops, you win a whole bunch of money. Everybody pays like $2 or something like that. Anyway, those are the kids on our partial eclipse with their eclipse glasses lying around in back. That's the pavilion there. That's Stu Walker, one of our SkyWatchers, and he has one of your big paintings, Mikey, right? And the kids there, and then and the kids were wonderful questions, just really great, really smart kids. Then I wanted to share this. Our nephew lives sort of east of Vancouver in Chilliwack in Canada. And these were ones, he said he didn't see much with his eyes, like we all know, but he got these two with his camera. And he was working that night, actually. He does truck repair and stuff, and I'm not sure what that thing is, but yeah, that's a couple of two of his many photos. I want to share this because we didn't see it. We slept right through. We went out Saturday and Sunday, of course.
Yeah. All right. That's it for you?
Yep.
Okay, so I guess the next thing we'll do here is take the dog outside. That's the next thing we'll do. Yes, we're apparently starting a canine branch of the SkyWatchers here. Barb, was there anybody? Was Carolyn going to say something or other stuff?
I want to do that when you're setting up this video? Yeah. Yeah, do you want to do it now? Yeah.
Okay.
No, I'm gonna talk about that. When you enable, be sure to enable sound.
Yeah.
Yeah, well, while you're setting up,
So Barb asked me to say something about, I'm president of Friends of Gilpin County Community Center, and we got a grant to do a couple of star parties this summer. So on July 27th, I think, we've got some plans to have a star party at Panorama Point, and so I'll send out an announcement about it. And then on August 10th, we're doing Gilpin Astro Day, and would like to get some speakers. If any of you want to come and talk about your work or talk about stargazing, I'd be happy to have you. But we're going to do something from about 1 to 4 in the afternoon at the Friends of Gilpin County the Community Center. Then break and then go up to Panorama Point and have our second star party. So those 2 star parties are actually courtesy of the Alan Green Memorial Foundation, which is a foundation that promotes outdoor recreation and recreation opportunities. So as soon as I know that we're setting the dates for both of these in the next week, and as soon as I do, then I can give it to Barb and she can send an email out to everybody. But that's what we're doing.
Anything else? Okay, well, we're ready for the video then. All right, so this is another thing we're gonna try to see if we can. Did you need to say anything about this?
Yeah, this is what you slept through.
Okay.
If you have been up all night long, there were no clouds. So everyone said, where did we go to see this? And we walked out the front door. And this is from our deck, fisheye lens on my Canon 5D Mark II. And this is what you see. That is before midnight. The flow of the change.
So we got every 15th minute or something.
15-second exposure.
Oh, 15th minute.
Took 15 seconds, left 5 seconds to write to the drive and then cycled around again. So.
It didn't look like that,
What were the beginning and ending times of the video?
What's that?
What was the beginning and ending?
Beginning was just after sunset, and you saw the sunrise. So that was all night long.
Did you hear that answer, Clark?
Yes.
Okay,
Okay.
all right.
Well, I just wanted to say one other thing. I did get a email from Y. Chapman, Clark's wife, who just had the question. And she sent me a picture with all those colors. And I said, I don't think Y does Photoshop. How did she get that? And then, next day I saw people had taken these. I couldn't believe that Y had gotten these. So she was the first one to get it for us.
Okay, so Barb, if nothing else, we're ready for Michael?
Yeah.
Okay, so for everybody here and everybody at home, this means we're going to be doing a computer swap and try to get it right. We'll see. There'll be a little bit of period of chaos here while we do that. Okay, so.
Hey, everybody, this is Joseph, my friend, who came up and is my lovely assistant. Actually, he knows Max better than I do and has solved all kinds of problems for us. Now I have to live up to it.
So I believe, yep, we are being heard.
Return it.
You don't have any videos on the.
Thank you for your time. That looks like it's changed.
Oop, I next. Accidentally pressed the slide. Stop.
So, right here, so quick check, can people hear us at home?
Yeah, sounds good, looks good.
Yay,
We
okay.
good?
Thanks, dude.
All right, thanks, Joe. Thanks, Joe.
So,
Here's
Joe,
Mike.
yes, so Joe is with that. Just enjoy. Oh,
I might.
no, you know, he needs so much help. So tonight. Kinds of things, one of which, of course, is craters. Now, a lot of people here know a lot about craters, but they're fun to talk about. They're fascinating to me, and I have some kind of quirky historical stories about them. Tonight's talk for me will be a little less focused than they usually are. Thank you, by the way, to Coal Creek Canyon SkyWatchers. Usually I have some specific thing to talk about, but tonight we're going to wander a bit and as you know. Right? So I'm going to pass out a quiz. See how much of this you can. Just asking, sure, and we'll talk about them in a while. Crater types. So there are craters all over the place, and of course, right next door, our own natural satellite, the moon, is covered with them, but so are many of the moons throughout the solar system. Surfaces of rock and of ice. All these craters come in different forms. Some are filled with dust. Others are strangely formed because they happen in either a wet environment, like on Mars, where there's water beneath the surface, or they happen in an icy surface. And so what we wonder, of course, is why are what happened? Oh, my computer is having a little memory problem here. I have those sometimes too. That's the little wheel of death going around there. Hang on. There we go. Okay, what makes a crater? There have been theories all along. People could see craters on the moon since back in Galileo's time. But nobody really knew why they were there. And early on, one of the most popular ideas was what I call the pancake idea. The idea was that you have this hot liquid surface and bubbles come up through it and burst and leave these little holes. If anyone here has made pancakes, you've seen craters like that. But there's something else going on Earth that looks a lot like the craters on the moon, at least superficially, and that's volcanism. This is a volcanic crater in Death Valley, Ubi. It's about a mile across. And if you don't know a lot about the details of the craters on the moon, this could fill in for one of those. So for a long time, volcanism was the main idea, the most popular thought. But it turns out that things fall down and plonk on the surface, and that's what does it. But this presented some problems. People did tests with rocks and mud, and they would find that, yeah, you could make a crater, but the rock was a big chunk of the center of it. And you don't see that on the moon. Why is that? There was something missing from our knowledge. This guy comes along named Ralph Baldwin. Anyone heard of Ralph Baldwin? I thought so. Bob Grimm's all over this one. So Ralph actually studied bomb craters from World War II and wrote a very obscure book on the subject. And he theorized that the craters of the moon had something to do with explosions on the surface. The work was not widely read at the time, and the idea was not very popular at the time. But you can see these craters from bombs in World War II look a lot like the craters that you see on the moon. And so Baldwin may have been on to something. In fact, when you make a crater, a thing falls down from the sky, comet, meteor, asteroid, lands into the surface, but look what happens to the layers of rock. This is really fascinating to me. In the explosion, they bend up and open like the petals of a flower, okay? And in fact, this is what we see in samples of bomb craters as well as the craters on the moon when we have detailed enough images. So there are all kinds of things floating around out there that could ruin our day. These are all to scale. Each of these checks is a kilometer, or no, half a kilometer across, I think. Comet Hartley, this is Gaspra. There is Comet Halley with sour cream and chives. And here is Itokawa compared to the CN Tower, okay, in Toronto. So these things are impressive, and this is a little moderate one. Of course, one of our favorites is the Chicxulub meteor crater in the Yucatan. You can't see the crater very well unless you're doing a gravity map, or unless you're mapping the Mayan cenotes, which follow the shock waves through the limestone across the landscape. In a way, the Chicxulub impacts helped to give birth to the Mayan civilization, because the Mayan civilization was built around the waterways that linked all these cenotes. Very, very important to the landscape there. Most of Chicxulub is in the ocean floor up there. But if you drive right down to Trinidad, you can see this. This is a layer of iridium. Iridium is a fairly rare metal on Earth, but it's very common in some types of meteors. And it turns out you find this layer right above all of the dinosaur fossils. Lots of dinosaurs under the iridium, no dinosaurs on top. So that's a clue. Suspicious, yes. And of course, we got asteroids that are really big that would definitely change the course of events here. Ceres is, in fact, considered a dwarf planet. Vesta is the second largest asteroid. So craters change depending on where they form, the kind of surface that they form on. the bigger they get, the flatter the bottoms are. If you have ice, they're gonna look a little bit different. Okay. And some of them cast out material, and we call these ray craters. This is a simple crater, very small, complex craters have a central peak in the middle. Excuse me. I have allergies, by the way. This is commonly known as the splosh crater or rampart crater. You have liquid under the surface, and it makes these ramparts around the edge of the structure, primary structure of the crater. You can reach it with rivers. We've seen this in Martian craters. Here's a very fun rampart crater. Simple crater in the center, right? Just a bowl-shaped thing, but outside of it, it's a complicated affair. So, you get these balls out there that have been pummeled with so many craters that they are crater saturated. In other words, when you form one crater, it wipes out as many craters as it forms. So there's a stability in the population. You can't have any more craters than what is there. It looks like it's been battered by a ball-peen hammer, and we see crater saturation on lots of geologically dead moons that aren't moving things around on the surface. But there are lots of things going on tectonically that change the character of craters. These craters are on, does anybody know where this is? Enceladus, yes. Could be Europa. Some of the small craters look a lot like that. Yeah, Enceladus, of course, has lots of tectonics going on. It's got cryovolcanism squirting out of the bottom. I know people like that, but that's another story. Some craters get filled with lava or liquid magma from ice worlds, which would be water, of course. Here's one close to home, Meteor Crater in Arizona. How many people have been to Meteor Crater? Oh, very nice. Most of you, very good. It's a big hole in the ground, and look how close it came to the amazing. So it's a beautiful place. There are mine shafts in the center because they were looking for the meteor. It made sense that it would be down there. In those days, Behringer, who bought the site, and others didn't know that a lot of times meteors can explode before they hit the ground, and they certainly liquefy when they do their thing in the center. So you'll find chunks of meteor. We found chunks of this one, but the big central part often is kind of non-existent. You can't go dig it up. So here's a panorama looking across this beautiful thing. It's got some grass on it, which you probably won't find on the moon, but and erosion, you can see water erosion down the sides. These things you won't see on a crater in a vacuum, but we'll take a look at some of these rocks on the edge. And if you walk along the walkway, look carefully, you can see how they stack up, how they're moving outward from the interior of the crater, just like the petals of a rose. So, how big was the thing that made this crater? Well, it was about the size of 3 railroad cars. Okay, but that doesn't quite explain the size of it. There it is. It was made of metal. Okay, it's a metallic meteorite. And here's the crater from the highway. I took this out the window. I probably should have pulled over, but oh well. And look at the profile here, and then look at the profile of this Martian crater. Identical. beautiful things happening here. Different gravity, different atmosphere, but the dynamics of that explosion are so strong. The thing that comes out is roughly the same. Here's a little crater on the edge of a really big crater on Mars. So we've seen lots and lots of craters from ground truth using the rovers. So yeah, we've got these big things floating around out there. Here's another one, Comet Hartley 2 compared to the Eiffel Tower. A lot of these are peanut shaped, not round things. And of course, then we have the beautiful rayed craters. The two biggies on this side of the moon, of course, are Copernicus and Tycho, two of my favorite craters. There's Copernicus. Here's a close-up of it. You can see how the stuff is just draped across the landscape in this titanic explosion. But what if you do it on ice? This is the crater Quill on Europa. And this is a classic ray crater.
Question,
Yes.
are the rays made up mostly of the material that was splashed out of the?
Yes, not necessarily from the impactor. That's correct. Yeah. Yeah. So here are a bunch of moons, the Galilean satellites and our moon compared to the Earth. Io has no impact craters. Well, I think we've identified 5 or 6, something like that, really small ones. Mhm. Yeah, they get covered by all this volcanism. Europa, they kind of slump away, although I'll show you a couple small ones in a minute. Ganymede and Callisto step down in terms of geologic processes. Callisto is dead. Ganymede is somewhere in between Europa and Callisto. And in fact, there's some terrain on Ganymede that looks exactly like Europa. It's really fascinating parallels. But here's a close-up, couple of the best close-ups we have of Europa. They are building there, by the way. So that's the dome in Florence. Okay, this is the Brooklyn Bridge. And if you look very carefully in these images, you can see just a smattering of little bitty craters. So the little craters survive for a while. Big structures, the ice just can't support them. So here are simple craters, bowl-shaped craters, small, mile across something, and they get a little bigger. And as you get bigger, the middle stuff in the explosion sloshes back and gives you a central peak. When there's a big crater, it makes little craters as the stuff splats away, and these are called secondary craters. You can tell them because they're all in these nice little lines. There are some spectacular secondary craters all around Copernicus. If you look at it in a telescope, you can see them really easily. There they are. I wrote it down just in case I forgot. And this, this is called a ghost crater or a palimpsest. Anybody know what a palimpsest was?
Writing over old writing.
Yes, writing over old writing. So back when people were using parchment or paper was very rare, this is usually for parchment, they would pour milk on the ink and scrape it off so that they could reuse the paper. But archaeologists, calligraphers can go in with x-rays, and sometimes you can see them just naked eye. You can see this more ancient writing underneath the new stuff, and that's what these craters are named after. A palimpsest. Great party word, remember. Here's a crater that is just crazy. But what I liked about this one's on Mars, all these little funny patterns are very typical of tundra here on Earth in subarctic regions, where you get ice just under the surface that breaks into these kind of polygonal forms that hump in the middle. So we can, a crater can tell us what's going on just beneath the surface, which is nice. If they get really big, they start to get multiple rings, and multiple ringed basins are called impact basins. They are really important. In fact, one astronomer told me that you really can't understand the moon unless it is within the context of impact basins. They have that much effect on everything on the surface. And I want to talk about one elegant, beautiful multi-ring impact basin on the moon, one of the prettiest ones in the entire solar system, I would say. And it's right on the limb, it's right on the edge of the moon. This is Mare Orientale. And this is what it looks like in a telescope. You can't tell much. There are chains of mountains. They named them as mountain chains. And they could see that there were kind of spots of dark Maria, but it was a little hard to tell what was going on there. So Bill Hartman comes along. He's an astronomer in Tucson, Arizona. And when he was a graduate student, he was under the wing of this gentleman. Oh, this is Bill Hartman. Gerard Kuiper.
Sound is breaking up.
We've pretty much lost sound. Anyone there?
I'm trying to get a hold of him. Just a sec.
So it's because we really understood the significance of this multi-ring structure. And of course, there have been many others discovered since then. But it reminded him of someone taking a BB gun, you'll shoot your eye out, and hitting a window with that same kind of pattern. So again, finally, it became really clear that impacts were the way these craters came about. Now, of course, there are volcanoes on the moon, volcanic craters and vents, but they do look different. Impact craters have some very classic characteristics. So let's see how you did on your quiz. Ready for the answers? Here we go. Secondary craters. Hello. Yeah. Impact basin. And now the little bowl-shaped guy is simple crater. Good, good. Ray crater. Limpsest, ghost crater, and finally, I hope, did anyone get 100%? All right. And not even close is okay for this group too. No worries. This is a non-threatening environment. So I just want to close the crater section by this pretty little simple crater on Mars. The detail we're getting with Mars Reconnaissance Orbiter, with Lunar Reconnaissance Orbiter, is just astounding. The things that we are seeing now on the lunar surface and the Martian surface. It's really inspiring. So we look at the moon now as the Artemis project comes along, and we wonder about resources. One of the most important resources for future stays on the moon is going to be water. Water is very handy. You can split it up into hydrogen for rocket fuel and oxygen to breathe. Is anybody breathing here right now? How many people are breathing? Good. Okay, that's a good thing. Keep that up. You can use water for that. And you can also use it for water, for drinking. And it turns out that there are places on the moon that have water. For a while, the theory was that it was a very desiccated world where if there was any water, it was not going to be accessible, but it turns out that the poles have permanently shadowed areas, and those may be cold traps where water can gather. People knew about these cold traps, or at least thought about them, and their juxtaposition to Big Tall Mountains for a very long time. People like Camille Flammarion, would look through a telescope, squint at the South Pole and see, oh, look, there's a peak sticking up. And he thought maybe these mountains were peaks of eternal light where the sun never set on these little spots. And wouldn't that be interesting? So as people looked at these things, don't get them confused. They also, some people reported seeing some spectral stuff going on, kind of rainbow colors, and they thought, well, maybe there is snow on these mountains, snow or ice. And so here's a painting I did for an upcoming book of the peak of eternal light as envisioned by Flammarion. Of course, the moon's mountains don't look like this. In fact, the peaks of eternal light, here are a couple. They're nice and soft. Great places to land, by the way. This is Malapart A, Shackleton Crater off in the distance. And these are the primary targets of the Artemis lunar missions to return people to the moon. The reason is that Artemis wants to do it right this time. They want to do it for good. They want to send people not for flags and footprints, but to establish a place where you can live and work and do research. And that's very exciting. By the way, speaking of Flammarion, does anybody know what his other passion was besides astronomy? This is a book he wrote called The World Before the Creation of Man. And yes, it was about dinosaurs. And it had some cool pictures in it. Really great reconstructions of dinosaurs that we didn't have many pieces of at the time. So it's pretty fun to page through that book. So here we are, modern times, looking at that same South Pole that Flammarion did, and we are finding, yes, that there is apparently some water leaking out. At least there's hydrogen in these places, and that typically is a clue that there's water down there. And so we've sent a whole bunch of things to the moon to try to find it, to try to figure out how much water there is. It's one thing to say, okay, there's a little bit of frost here and there. That's not going to do you much good. If you can find a lens of water, a buried lake, man, you're in good shape. But do they even exist? Nobody knows for sure. And that's what we're trying to find out through some of these precursor Artemis missions like La Crosse and Lunar Reconnaissance Orbiter. So let's transition, shall we, back to a cold January morning, 1848. James Marshall was building a lumber mill. Sutter's Mill was designed to put out mostly lodgepole pine and what was the other stuff? Ponderosa pine, I think. The timber was destined for these Wild West towns of Sacramento and San Francisco that were just getting going. And so Sutter's Mill was designed to crank out all this wood, but the water that went through it, this guy Marshall noticed one day that there were some glimmery things in that pile of dirt coming through the sluice, and of course it was gold. That was the beginning of the great gold rush. Well, there's a new kind of gold rush on the moon, and it is the one to find water. Water is now the new gold rush on Luna. Lunar Prospector and Chandrayaan from India, both were designed in part to look for evidence of water. Chandrayaan had a little moon impact probe that slammed into the surface, and it looked at the plume and in fact saw some very good evidence for the presence of water. LRO and lacrosse brings the game up to another level. Lunar Reconnaissance Orbiter is still returning amazing data, and I love the scenario with lacrosse. Lacrosse traveled out there with Lunar Reconnaissance Orbiter. That when you send a big spacecraft out, it drops off a big stage. Well, they arranged this mission so that this stage that dropped off LRO into just the right orbit, the stage would hook back around and come in and ram into the South Pole. On the stage was a little bitty package, a little bitty satellite called lacrosse that let it go, so it had a couple of minutes delay before it followed to its doom. And when the stage hit in Cabeza's crater, it sent this huge plume of debris up that little lacrosse flew right through, and it definitely found water. In fact, we were able to tell about how much water, and I'll tell you about that in a minute, but we'll be able to tell a lot more if the Viper rover, which is coming in roughly 2025, is successful. It's designed specifically to sample in situ the dirt around there and look for more direct evidence. So stay tuned for that. The whole idea, of course, is that we are going to need to find these places. There may be some outgassing spots. It would be lovely. There may be only water in the matrix of the rocks. That would be hard. Okay, we would have to grind things up. We would essentially have to strip mine. Probably not a great idea for our first travels to the South Pole, but we'll see. And notice the Earth is upside down here because we're in the South.
Aren't those people there?
Those are people there.
They have
Yes.
suits on?
Suits on. They better have suits on. So let's look at the numbers, though. Just how promising is all this water deal? Well, Cabeza's crater, where the little lacrosse thing hit, here is a cubic meter of stuff in Cabeza. Okay. And how much water was in a cubic meter? About 8 ounces, which is significant. That's a lot of water. That's a good concentration. But we have several other places where we can tell that water is at least mineralogically locked inside. And one of those is with the Apollo regolith samples. The water molecules there are generated by solar wind primarily, probably because the temperatures are too high to have ice. And you would need an area 150 times the size of that Cabeza meter square to equal the water, not so promising. And in the more ancient places, the lava flows, where there's water that may be mineralogically trapped from really, really ancient times in the moon's formative period, you need a 650 times greater area, and that's the optimistic number. They say 650 to 6,500. So you're not going to get a lot of water in any of these more equatorial sites. There are probably ways of doing it, but it would involve a whole lot of scraping and nasty things. We continue to go out there with all kinds of things. This is Odysseus. That bent one of its legs and almost fell over, but it still survived the landing. It had some interesting experiments on it, one of which was not able to deploy. It was a camera to look at dust that was blown up as this thing landed. Dust is a huge, huge problem. It's a big concern with the Artemis architecture. It gets into everything, including machinery. It's very dangerous. Lunar dust is like a bunch of microscopic arrowheads. It's basically crushed glass, not good stuff. It's bad to breathe. It's bad to bathe in. So we want to know about it, and this we have not yet been able to actually watch the plume of a landing, but that is coming, I'm sure. Now, there was another experiment on board that just cracked me up, but it's really intriguing. There's a Lone Star Data is the company that is doing this. Christopher Stott is in charge of it. What they are interested in is a planetary backup of all humanity's knowledge. There are all kinds of nasty things, as you know, possibly even firsthand, floating around on the internet. There are viruses, there are people stealing data. Their concept is to sequester a storage unit on the moon that you can download knowledge to, but that is not accessible to this other nasty stuff. I'm not sure how they do that, but they do have a plan. On its way to the moon, Odysseus sent and received things like the Constitution and the Bill of Rights. So it was kind of a proof of concept flight. But the idea is to have a new Library of Alexandria on the moon, a place where we can safely store the knowledge of humanity. I think that's an interesting thought. And what I like about Artemis, there are some things I really don't like about it, but one thing I do like about it is people are thinking outside of the box a lot. They are trying new things, experimenting in ways that we never have before. And I think that's very, very healthy. One other aspect of Artemis that I appreciate is the idea of historical preservation of sites on the moon and Mars and beyond. The idea being you need to preserve those footprints of Neil and Buzz, okay? Have a place where people can come and look, but hands off. And well, it's something that we need to think about. Right? There are ideas to do really big projects on the moon. This was a concept that's been floated for several decades to erect this network of solar panels that you would then beam energy down to the Earth. It may look good on paper, but it sure doesn't look good on the moon. I really don't like this. I don't like invasive things like this. I understand progress, but now is the time for us to be responsible. Now is the time for us to think about what we're doing. Do we want to go to the world next door and make it look like a strip mine? I'm not sure that's the best approach. We may need to do that in some places practically. We'll see. But we can also be responsible for how we attack this new frontier. Maybe we can live with it instead of on it or despite it. And one group that is working to that end is called ICON. They are building three-dimensional homes, and NASA has actually commissioned them to figure out how to take lunar regolith. Regolith is just dirt made of crushed rock, basically, and melt it and turn it into 3D houses. They've already done it here on Earth. They've built whole housing developments here on Earth using 3D printing. They have the machinery that will work in a vacuum. They know how to cook lunar regolith. And so they're well on their way to being able to making the first habitats and perhaps storerooms or whatever structure that our earliest inhabitants will need on the moon. There are several other companies working along the same line. So they're based outside of Austin, by the way. So here we are looking out from this beautiful planet of ours to our beautiful natural satellite and the beautiful planet next out from us. Hopefully we look there with responsibility and respect. What we learn from these things out here is not obscure knowledge. It's stuff that benefits the entire world, the entire planet. And it's up to us to apply that knowledge the best way we can. I think in general, we do a pretty good job. So exciting times. Keep watching the news. I did bring a few books. Feel free to look through them. I also brought some art. Some of it is original. Some of it is has prints. And one of those, the big painting back there, has a hidden picture in it. I won't tell you what it is. A little more of my art is here at my website, along with some notes about writing and science and things. If you are interested in astronomical art, if you're interested in becoming an astronomical artist, IAAA.org, International Association of Astronomical Artists. It's a wonderful tribe of creative people who is very welcoming. So, and there's my little thing with a hidden picture, but you'll just have to go explore. Do we have time for questions?
Yeah, sure.
We do. Let's have some questions.
Could you repeat the questions just so?
Yes. Could I repeat the questions?
So the Zoomers can hear
Yes.
But one question I have, can you say a little more, I mean, you were one of our speakers about your book before it was the planet, the Earth one. Yeah. Could you say a little more about what that book's about?
Sure. So Planet Earth's Past and Present is my latest Springer book. Springer has been really fun to work for. They're an academic publisher. They don't have a lot of money or marketing, but they have wonderful editors, and it's just been a real pleasure. Planet Earth's Past and Present is about the development of the Earth and the many times when it appeared like a very alien world. Times when there was no oxygen here, times when we went through snowball epochs that in some ways resembled the Mars of today. Of course, the Hadean period here was somewhat like, had parallels to Venus of today. And so it's just kind of a romp through time showing the different alien Earths that have been here, leading up to this place that we're now living in, which is not so bad. What else?
Other questions or comments?
Yes.
So how much water do they want to get out of the stuff, the moon?
Right. I mean, it's a great question. The more you get, the more practical it is. initially, it's just gonna be an experiment, obviously, a proof of concept. But to really make it practical, you've got to start generating enough water to support living people. The whole goal is to be as self-sufficient as we can. Of course, it's really hard to be self-sufficient on the moon. It's easier on Mars because of the resources there, but there are a lot of resources on the moon. It's just harder to get at, and water is one of those. So I think it'll be an incremental thing, the more people we get, the more pressure there will be to get more water, if in fact it's an available resource. We don't even know that yet. But it does looks promising. Carroll.
You want to talk some more about the sources of the water on the moon?
No, I do. Oh, all right. Yeah, so.
Where did it come from?
Where did it come from? Great question, actually. So the locations that are permanently shadowed have not always been there. The moon has not always been at the same tilt as it is today, but it's pretty stable over time. And so these dark places probably don't have water from, from day one. Instead, you get incoming water from carbonaceous chondrites, from comets, certainly. And this water will migrate to and kind of collect in these super cold areas. The reason that it has to be so cold is because there's no air. So you're in a vacuum, and water tends to vaporize in the vacuum. It just goes away. But if it's cold enough, it'll sit down there and gather. And so the PSRs at the poles have that kind of water. There is water generated by solar wind, but it's kind of on a microscopic level. It's not very significant in terms of getting a glass to drink. So lemonade, it takes a lot of water to make lemonade. So, you got that. What else?
Clark Chapman here, can you hear me online? Yeah, I'd like to make a comment. I began studying craters in 1962 at the Lunar Lab in Tucson, right at the same time and place that Bill Hartman was identifying the Orientale feature as an impact basin. And a couple decades ago, at toward the end of Ralph Baldwin's life, I worked with him to help him publish the last paper he ever published on craters. So I know a lot about craters, and what I want to say that I'm a professional planetary scientist, and you, Mike, are an interdisciplinary wonder who have a much broader perspective on space and planets. But when you delve into the actual science about craters, you get it all right. And in your previous talks that you've given to this group, I've been very impressed about how you get the exact science so right, so people can rely on what you had to say about craters.
Well, thank you, Clark. And the fact is, the only reason I can do what I do is because of people like Clark Chapman, Bob Graham. These scientists are generous with their time and their knowledge, and so I really appreciate that.
Bella, had a question? Oh, yes.
So housing developments have been made on Earth as a test for what materials can be used to build structures on Mars, but could those methods be used on Earth, and is there indication that they will be used on Earth in order to build housing developments in the future for commercial use?
Yeah, in fact, ICON is building a set of low-income homes in Mexico. A whole community of them, 3D printed suburbia, which is pretty cool. And they are doing the same in Texas and California, I think. two places where they're starting to, what they do is they build a house. People come and look at it as a model home and order one, and then they don't build them on spec much because they can't afford it. But it's a fairly cost-efficient way of doing things. It's a very simple structure. It's very strong. It would do better in a tornado than most things built with metal and wood. So it's a very promising thing, and that's a great question. They're thinking in those terms already, which is great. Yeah.
Mike?
Yes.
You said that the lunar regolith is pretty nasty stuff. Yet you also said Icon has figured out a way to do their 3D printing thing with lunar regolith?
Yes.
You melt it, you gotta melt it.
Yeah, you melt it.
Okay.
It's on a short of no.
So then, yeah.
Yeah. Yeah, it's also significant to realize that none of the Icon employees will be on the moon when this is happening. So, I don't know what that tells you.
Takes a tremendous amount of energy. This is the big problem with this.
Yeah.
Get enough, what do you use, solar concentrators or something to, it's a lot of energy to melt rock, basically. And
Yeah.
spray it out of the air.
Yeah, they were a little reticent to tell me details on power sources, because I did ask them that. But he said that they were exploring both solar and nuclear. The nuclear is, it does make sense for that, yeah. But you would need a small reactor, and this country isn't building space, space-based reactors, on that scale at this point, but a lot of times, need is the mother of invention, so, yeah. So we'll see what happens.
Space did a test where they took a simulated lunar regolith and got a water out of it. And we're also working on fission.
Really?
Yeah, I don't know if we're gonna use fission for the regolith, but it would make sense.
Yeah.
It's the most cost efficient way to do it.
Right. Okay, interesting. Yeah, you guys are doing all kinds of cool stuff out there. I hope you do a tour. Right, anything else? Yes.
How did you first get inspired to be an artist? Like, were you really young?
I started painting when I was 11. The first painting I did was of our dog, Sandy, Cocker Spaniel. And he didn't like being painted much. And then I did a pheasant, and then the third painting I did was based on an Apollo 8 image that they brought back from the far side of the moon. And I fell in love with space and art. And so we never turned back, much of the chagrin of my bank account, but hey,
And what books inspired you? Yes.
Oh, sure. Bonestell, of course. When I was a real young kid, my father sat me down on his bed and dug around in the closet and pulled down this shoebox that had this loose leaf article from Look magazine or Life, the World We Live In by Chesley Bonestell. And it showed the ancient earth and these meteors falling into lava. And here was a place I didn't know about, and it was right under my feet. So Bonestell was definitely a big one, yeah. Barbarella, of course. I mean, for good science.
Oh, what other movies as a kid?
Oh, man. Well, 2001, we went, it came out just before my birthday. I don't remember how old I was.
68.
68, so you're gonna make me do math. So I was 13. That was a big year for me. I became diabetic that year, which taught me that I was mortal, and that was very good for me. And I saw 2001, and it was awesome. we all got popcorn right before the scene where Bowman goes through the portal. And so we thought, of course, that someone had put something in the pile. But it was definitely an inspiration. And of course, in terms of stories, Jules Verne, Ray Bradbury, huge Ray Bradbury fan. I love his writing. I think he's one of my favorite authors. Later on, Kim Stanley Robinson and others. So yeah, lots of influence. I'm sure all of you have lots of influences. That's the part of the celebration of life, right? There's lots of cool stuff out there, and you just have to engage and be energetic in a way. So, all right, what else? Anything else?
Any Zoomers out there have questions? Apparently not.
All right. Okay.
All right, well. All right, that's gonna end the show for you Zoomers. We're just gonna take a picture here and pack things up. So, Barb, if you want to have everybody, if we're gonna do a group photo, let's do it before we do the chairs, so we can just get that out of the way.